Welcome to Walk About the Galaxy, the subtropical astronomy podcast where the science is universal, the opinions are personal, and we say the syllable roid a bit too frequently. We are Strange, Charm, and Top the Astroquarks, also known as Josh Caldwell,
Patty Dove,
and Jim Cooney,
coming to you from the Walkabout studio at the University of Central Florida. Remember to subscribe to us on all platforms, including YouTube, Facebook, Twitter, and Instagram. Did I say Twinter?
Whatever.
We are also on something called the World Wide Web at www.walkaboutthegalaxy.com, where you can see how to order a Walkabout shirt and support STEM education at the same time. Contact us directly at wtg@ucf.edu, where we do one letter better than Mark Maron's WTF podcast.
Yeah.
Our stumper today is just a tough question.
Oh. Those are stumpers.
It is just a tough question. But there's no right or wrong answer for 30 years. Because the question is, do you think we will find definitive evidence of extraterrestrial life by 2050?
Oh.
And if so, are we talking bacteria type, microscopic organism evidence? Or are we talking SETI type, intelligent signals from distant civilizations, something in the middle? What do you think?
By 2050.
2050. Where this is.
That's coming right up.
That's 1, 2, 3, 29 years.
When's Clipper supposed to go? It's supposed to go pretty soon.
Clipper is launching in like 5 or 6 years. I think it got pushed. Oh no, that's Dragonfly I'm thinking of. It's maybe sooner than that. Maybe like a 2023 or 24.
Clipper,
Europa Clipper.
Yeah.
Yeah. Yeah.
You do.
That was kind of a half-hearted yeah.
It's an unenthusiastic response
think-
for what would be for a prediction of what would be an incredibly exciting thing.
Yeah.
That would be kind of like, do you think you're going to win the lotto sometime in the next 10 years? Yeah,
No.
probably.
Not really.
It's like, if you think it's going to happen, let's hear some enthusiasm.
Yeah. I mean, it was a questioning, yeah. So that was why it lacked the full thrust of my enthusiasm.
Okay, so you think it's 51% likely or something?
Yeah, kind of. Maybe like 60. I think it'll be something more microbial or bacterial.
Okay.
That we find on like a cometary or a Europa type or a
Within our
Dragonfly
solar
type
system?
mission within our solar system.
You're betting on finding definitive evidence of life within our solar system.
Yes.
Over some like extra.
Yes.
Okay.
Does it have to be live life?
No.
Yeah. So I'm going to go with my answer then.
Okay, cool. All right. You're sticking close to home, doubling down on soul.
Yeah, I mean, there's enough evidence that like there's transfer of things between planetary bodies, right? Meteorites hit other things. And there's enough evidence that like some of the precursors for life exist on things like comets, that even just having like a really warm impact for a while somewhere with the right energy sources for a while. We're going to find some stuff down in Europa or Enceladus.
Yeah.
Well,
Could be.
all right.
Could be.
I like your optimism. What do you
too.
think, Jim?
Hell yeah!
Oh, look at that.
All
There's
right.
the answer
There's
you
the
wanted.
appropriate matching of enthusiasm with content.
Yeah. I think Eddie may be right, but I also think the stuff we're going to talk a little bit about related stuff today. I think that's the most likely.
We are.
I don't know.
And what stuff is that?
That's finding biosignatures in atmospheres of exoplanets. Now that's not as definitive, of course, as the things you can find if you go to Europa or something like that. But I think that we're gonna see some cool signatures on these.
Yeah, like a whopping amount of oxygen. Or a whopping amount of
we're gonna model
methane or
12
something.
ways to Sunday and not be able to figure out any other way except life to explain it.
Probably not going to be phosphine.
I would accept. Yeah, right. Right. I would accept that in the context of this stumper is definitive.
Right. Yeah. I think we'll find that. I think that the techniques and for finding for analyzing atmospheres of exoplanets are improving pretty rapidly and are going to get.
And of course, that kind of chemical detection tells you nothing about what kind of life it is.
No.
It could be anything from bacteria on up.
Right.
Yeah.
Right.
Except to cyborgs. Once you're at cyborgs, then the chemical signature disappears.
Right.
If it's a planet
Maybe
full
they
of
need a lot of
datas.
freon for their cyborginess, and then you
Maybe.
might
So there's maybe this
CFCs
whole other
and stuff like that.
astrobiological realm of inquiry that we could go on. It's like, okay, suppose we evolve into datas,
Yeah.
Star Trek TNG data, what kind of, if it was a planet of datas,
Because otherwise,
no
data is
other
already
life,
plural, and it would be
no other biological life,
Oh.
then what would there be any signatures? There would be like excess IR, or some funky weird thermal thing indicating
They have to
the
see outgas.
energy. I haven't spent enough time around him.
The sad part of your question is, I think if you'd asked me that like 10 or 15 years
You
ago,
also would have said-
I would have said absolutely yes via SETI type things, like with old school detect. And now I think I'm just drastically less.
Yeah.
I don't know. I got the terrible feeling that the great filter is just ahead. And that,
yeah.
there.
Come on, Jim. You were so happy and enthusiastic a minute ago.
I just brought it down.
We were done.
Really
we were
jimming this right
we
now.
were like, really, we were there. We were good.
Yeah.
We didn't need you to like go, on the other hand, everything is terrible.
Sorry. Maybe.
Well,
We have enough of that in the world.
today we'll talk about a class of big little planets that may be habitable, as I say. Citizen Science Asteroid Project. And speaking of asteroids, how to stop one from hitting the Earth. Hint, it's not what they did in either Deep Impact or Armageddon. But first, this episode of Walkabout the Galaxy is brought to you by, this for you, Jim, Einstein summation notation.
Ooh,
If,
specific.
if Twitter's character limit is cramping your style when tweeting complex mathematical equations to your followers, maybe you should consider Einstein summation notation and lose those giant sigmas in favor of implied summation over repeated indices. Whether you're trying to solve the mysteries of the shape of space-time or just fed up with writing everything out in detail, try Einstein summation notation. Einstein summation notation. If your indices are doubled, bet you can't eat just one.
Einstein summation notation.
Very good. I like that.
Einstein summation notation is fun to say a bunch of times fast.
Yeah.
It is kind of fun.
It's very lyrical.
Yeah. I couldn't, so bet you can't eat just one is the.
Pringles?
I think it's
Or-
Lay's.
Oh, very good.
Yeah.
It's Lay's.
Yeah.
Yes.
One
It
of
seems
those
like
chips.
Pringles is once you pop, you
can't
just
stop.
can't stop
Same
or something
same
like
idea.
Similar concept.
Same idea, but
Different
wrong.
wording.
Wrong. yeah. That's fair.
I say that
How
on my
often-
students' exams a lot.
I-
Same idea, but wrong.
Right, yeah.
You failed.
The student comes to you, it's like, you explain to them how to do the problem. It's like, well, that's kind of the same idea as what I had here.
Yeah.
That doesn't cut it.
You can tell we started the semester again.
Right. So there, we have mentioned before citizen science projects.
We have.
And there's kind of I guess they're sort of the definitive platform for a lot of them.
Yeah.
This Zooniverse project that, or I don't know what the right noun even to apply to it.
The Zooniverse.
The Zooniverse. And they are sort of a structure that scientists who have large data sets that they can make use of citizen scientists, which basically just means the power of many, 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 many pairs of eyes
Yeah.
looking at stuff
Yeah.
to go through very large data sets and, use a human brain instead of an artificial intelligence to classify or flag things or say, hey, I found a weird thing. We've talked about, like, people have found planets
Yeah.
in some
Yeah.
of these things.
There's the green, the Voorhees, the green galaxies or whatever they were. And
Yeah.
there's been planets and all sorts of cool stuff.
So Zooniverse has a citizen science project on active asteroids.
Oh, I feel like that's a dangerous term.
Active asteroids?
Yeah. There's this goes back to our whole asteroid comet debate.
Yeah.
Morons.
Jim's going to rant.
No, I'm not going to rant. No,
What's your take on active asteroids? Is that a thing or not a thing?
Sure. I'm for it.
Yeah.
You're okay?
I'm okay.
Active asteroids are kind of like comets.
Yeah.
Because they like outgas and stuff.
Right.
Just like Data, maybe.
Yeah.
But
Right, but they're not comets.
they're not comets.
Yeah.
Or are they comets? I'm trying to trigger Jim.
I know. I'm
working-
gonna stay
I'm
calm.
trying to
gonna stay
trigger.
calm. I'm going to stay calm. I'll rant later.
Yeah, but basically they're things that are like, oh, it's an asteroid. It's on an asteroid-like orbit. And then we see sometimes like, oh, there's some stuff coming off it.
Right. So the idea with this project, right, is that the citizen scientists are going to look and see if they can see tails.
Yeah.
These images of these potentially active asteroids.
Yeah.
What's the data set?
The data set is astronomical.
Interesting. That was a very walkabout answer.
Yeah. It is the images taken with a dark energy camera.
Oh, yeah.
Which is a great name,
It is.
by the way. I bet it doesn't take pictures of dark energy, though. Mounted on the Blanco 4-meter telescope at Cerro Tololo International Observatory in Chile. It captures 50 times as many pixels as the average smartphone. I'm reading off the Zooniverse website. Sees about 10 times fainter than the next best asteroid survey.
Oh, well.
And so it allows the detection of faint features around an asteroid.
Cool.
So, yeah. I just seemed that I don't know. I get alerts when there's new Zooniverse things popping up. Frequently, they're biological or zoological.
Yeah, they actually. I mean, as you sort of can tell from the name, it started more with astronomy things, but they branched out to all these.
Well, you got the zoo, and you've got the universe.
Yeah, maybe. I think
that's a nice.
Yeah.
It's a nice bio.
But they have things like old weather records and stuff like that from ship's logs and I don't know, other crazy cool things.
Yeah.
It's weird to me that...
We'll post a link anyway.
It's weird to me that this is better done with like human eyes than it is with some computer algorithm. I guess the idea is you do it with human eyes and then you can make better computer algorithms to find things in the future.
That's one of the things. Yeah.
That's
it's
one
also
idea.
just like human eyes are better at detecting like anomalies and things like that. Like when things are different, but not in enough of a way that you can get a computer to detect it regularly because they're always different in different ways.
Yeah.
So it's like it is still our eyes are better. I mean, maybe with some of the machine learning stuff coming along, it's going to not be true anymore. But
but the catch with the machine learning is you have to
train it also.
the machine.
Yeah. Right.
Extensively.
And usually
you do it by this kind of things like having people figure out what the right answer is 1,000,000 times.
Yeah.
Right.
So
fun.
Yeah.
Maybe if I was teaching honors astronomy, that could be one of the projects. I always had them do a Zooniverse project.
Yeah.
Fun.
On another bit of space news, you had Addie about solar storms.
Oh yeah. Also Blue Origin.
Oh.
Launched.
Yeah. How was that? You got a hat.
I got a hat.
It's too bad you didn't wear it today.
For the launch?
I was there for the launch.
Saw your experiment
I had
go
an
up and down.
Experiment on it.
Did it work?
The rocket worked, which was nice.
Okay.
We weren't sure. It had a couple of holds in the launch.
It was a lot of delays for that launch.
If there had been one more, it probably wouldn't have gone that day, which would have been sad because we would have had to wait till a different day. But it launched. It landed both the booster and the capsule. I got a picture with the booster.
Nice.
Fun. And our experiment, parts of it worked, parts of it didn't, but we'll refly it in some amount of time and it'll all work then.
Great. Mm-hmm. Awesome. You'll tell us about the results at that time.
Yeah. I can tell you about some results probably before that, but we'll see. The other news, though, was there was just like a sort of a new study out, another fear-mongering study out about solar storms and how dangerous they are to our infrastructure.
Yeah.
We know this, but most of the time when we talk about it, so solar storms, right, coronal mass ejections, things like that, you have a lot of energy, high energy particles, a lot of things that can disrupt things like satellites we think about a lot because you'll have enough sort of disturbance in the force that you can actually cause like satellites to shut down or fry their electronics and things like that. When these big massive storms hit, there's been a couple of movies recently that have used solar storms in them.
Yeah.
For better or for worse.
Yeah. Hollywood has turned to that.
Yeah. Because they're like, oh, this is a thing now we can use.
Right.
They used it in, we talked about it one time for all mankind. Little dust on the surface. Anyway, but it turns out, but it can also affect grids on the Earth because you get weird coupling with like electrical grids and stuff like that. And
I don't really understand the physics of that all. Because it's weird to me that electrical grids seem like these really robust things that you'd need physical disruption to mess up. But
Yeah.
apparently that's not the case.
So a lot of it has to do with like how you disrupt transformers and things like that, and how it surges in the system. But there are some other more
Maybe
complicated
that's
things.
happened on Earth.
Yeah. So there was the Carrington event, and there was huge brownouts in like Canada and stuff like that in 19 or 18. Sure. I don't know. It's been a long time. But anyway, there's now new warnings about how it might affect our internets. The interwebs.
Do not mess with my internet.
Seriously, how am I going to watch Netflix?
And it's not just because of satellites. It's because of like ground lines of interwebs.
Yeah.
Are big electrical conductivity cables that are going to potentially get disrupted.
Yeah. I was surprised. I shared your puzzlement over the ability of these events to mess with our stuff.
Don't mess with my stuff.
Yeah.
It's weird to me. I
So that's why we have space weather and why we're closely monitoring the sun.
Yeah. Part of it is we just don't have a lot of good data. But there's a lot of people studying this these days, and there's a lot of infrastructure in place to study it more because it's a national security concern. It's just a power grid concern, all that stuff.
Speaking of things that can mess with us and of asteroids, asteroids are things that can mess with us.
It's a true statement.
And more likely to create some really nasty problems on a long time scale, at least. Maybe not on a short time scale, but on a long time scale. Well, this is the long time scale. This is a short time scale. Then a big solar event, in different ways anyway, we're going to get hit. Some,
we get hit every day.
Some non-trivial chunk of asteroid is going to smack into the Earth at some point in the future. Probably not in the next, small number of years, but quite possibly in the next large number of years.
Yeah.
And we've seen a lot of this. Another thing that Hollywood likes to explore.
Yeah.
And
impacts
and what to do about it. And we've frequently talked about Deep Impact, about a comet on a collision course. And the movie came out the same year, Armageddon, about an asteroid, where the Hollywood way is to send some heroic individuals out to put some nukes on those suckers and take care of them that way.
Makes sense.
Problem is, and this is, if there was one great scientific shortcoming of Deep Impact, the movie that I was an advisor on, it's that they blow up the asteroid, the big
spoiler alert,
the comet, the big piece that they split the comet in two, and both pieces are coming towards the Earth, and after they've split it. So they go again to blow up the larger fragment. And the timing is, I will say, in defense of the movie, not definitive about when that happens compared to what you see then happening next. But they blow up the big thing. It's a bunch of little fragments. The implication from the movie, though, is that all those little fragments hit the Earth, and that's therefore harmless because they're little. Right. But if it's all of the fragments
it's still
hitting the
energy.
Earth, it's still the same amount of energy coming into the Earth, and it's enough energy to produce global firestorm, for example. Right. So it's not just enough to shatter. You really need to make it miss.
Yeah.
Right.
Yeah, it's definitely different if a big thing hits rather than a lot of little things. That I'm sure the energy gets dumped into the atmosphere more if it's the little things, but still, like it
depends on the amount of energy you're dealing with, right?
But still, it's the same total amount of energy, and if the total amount of energy is high enough, you're in trouble.
You're in trouble.
How it's being delivered.
Either way, yeah.
So deflect it.
Deflect that sucker.
Deflect it. How are we going to do that?
There's currently actually a mission called a Double Asteroid Redirection Test, DART, that is in the works. It's supposed to launch later this year.
Double or direct? Double,
direct. I don't remember.
DART.
It's DART.
It stands for D Asteroid.
Double Asteroid Redirection Test.
All right, she was right.
What are the odds?
Questioning that it was right. I was like, what does the double mean?
It's because I think it's double because they're looking at both the.
Well, it's a binary asteroid.
Yeah.
Oh. And they're shooting the moon of the asteroid.
Didymoon.
Yeah, so the asteroid is named Didymos, right?
Yes.
And they're going to hit Didyleast.
It's not Didyleast. It's also not Didymoon anymore. It has a different name.
But which is a tiny little thing. The asteroid itself is small, and its moon is even smaller. but we're also hitting it with something that's even smaller.
All right, so what are we doing to it? What's the idea?
The idea is just to hit it and see how much its orbit changes.
Big impactor.
With a big impactor.
And then watch it with a spacecraft and see how much its orbit changes.
Yeah.
Because that'll tell us about how that impact affects its dynamics in that small gravitational system, which gives you information more generally about how those things will happen.
It's a pretty basic physics experiment, but in a sort of scaled up real world situation of asteroids and redeflection. So actually one way that people have talked about redirecting an asteroid is not by hitting it with matter, but by hitting it with photons differently. Yeah. And you can do that by...
Get away, asteroid!
You can do that by changing the reflectivity of one side of the asteroid and then just let the sun do its thing differently than it was doing it before.
You just go up and paint the asteroid? Yeah. You spray paint the asteroid?
You set off a glitter bomb.
Glitter bomb, yes!
glitter bomb the asteroid.
Yeah.
And you either increase or decrease the reflectivity depending on what your mission design is.
You're really going to regret that if the asteroid then ends up hitting the Earth, because it's going to be so much glitter.
It's impossible.
You're never going to get rid of that glitter.
Impossible to clean that up. But otherwise, you hit it with stuff.
Right.
Yeah.
And so there was some recent work done on how hard can you hit it before you break it.
Yeah. One of the things astronomers and planetary people study a lot is impacts.
Yep.
And so there's some people who just like to do some impact experiments in the lab.
Yep.
And we do that, but we do it very slowly.
We do gentle type stuff, but it looks really cool.
It looks cool
when we do ours in 0G.
Yeah.
So out at in the Bay Area, NASA Ames Research Center, they have a vertical gun facility where they can shoot things at about 6 or 7 kilometers per second.
Yeah.
Which is decent speed. That's kind of asteroid belt kind of collision velocity. Yeah. And so they did some experiments
on lots of different types of meteorites.
Actual pieces of asteroids,
yeah, to see what it took to break them apart.
Or to put it another way, what it took to not break them apart, to nudge them, if you will.
Yeah.
And as we saw with these asteroid sampling missions, particularly with OSIRIS-REx sampling Bennu, the asteroids are not super they're like granite,
No,
they're not like,
they're not solid.
it's a rubble pile. We think boulder, we think concrete.
Yeah, and some of the bigger ones are probably.
There's going to be chunks like that.
And there's some small ones that are chunks that are just solid chunks. But a lot of them are these just
it's like very crumbly stuff. Sort of more like ash, kind of like burnt out charcoal briquettes that would crumble in your hand.
Yeah.
And so if you say, okay, we're going to smack into it and knock it off in a different direction, next thing you know, all you did was plow through it.
Yeah.
And you shattered it, but all the stuff is still going in the same direction and still hits the Earth.
Yeah. So they studied and they found that some things are easier to sort of nudge as opposed to break apart than others, certain types of materials. But that you actually sort of need to have better, gentler nudges to keep it from breaking up. So you don't really want to smash at something really hard. You want to sort of just gently push on it.
Yeah, and maybe, as light would do. And so doing it with matter is maybe a little bit more of a challenge, but
It makes, it's true too that these studies are done on meteorites that are sort of one chunk of a rock, right? So they have their own cohesive strength.
Yep.
And you can think about what it takes to break those rocks up. But that's, like you said, that's one aspect of it. But then there's also how those rocks are then all put together in the asteroid that makes it even more fragile.
Right.
So, complicated.
Key thing is to find these things early enough and get to them early enough that you don't have to push it very far.
Right.
Yeah.
A little tiny angle then results in a very wide miss, which will make everybody a lot happier.
And wide miss for many years to come, because there were some studies that were if you could deflect it, but then you deflect it into where in 30 years it still hits you.
Right. Yeah.
It's that's not quite what we wanted. But.
Is it another strategy that's along the same lines? Just put a big heavy satellite up there and just park it nearby.
Gravitational tugging.
Gravitation moves it a little bit.
Right.
Yeah.
Yep. Another way to gently tug on it with the force of gravity.
Maybe this is a good trash removal technique. Is in the future we just launch giant balls of trash
to deflect
asteroids.
Yeah.
I like it.
Okay.
I'm pulling from Futurama a little bit on that one.
I was thinking of Avenue 5 on HBO, where there was there was a sewage dump that orbited the spaceship.
Ew. Ew.
Well, it sounds like we've transitioned into the realm of trivia.
Ooh.
It did sound like that. I heard that sound.
It did, yeah. There was a distinct trivia transition sound.
All right. Here's our trivia for...
It's special Top Court trivia.
Top Court trivia.
Well, before we do the trivia, we should say that one of our... So our trivia today is related to some of our biggest fans.
Oh.
One of which, of course, is the daughter of our strange cork.
Oh. That's me.
Leah Cowell. Yeah.
They're talking about me.
Oh my gosh.
Yeah, your daughter is one of our... So it's very exciting because we have some news.
Oh, I'm
Space
excited.
news? We already did space news.
This is more terrestrial news.
Oh.
Okay.
And that we're going to have a new fan very soon.
A new
Our
cork.
second biggest fan.
Yeah.
Oh, okay.
Which is...
The littlest quark.
Micro quark.
She's currently a micro quark, yeah.
A micro quark. So
Yeah.
it's very exciting.
Yeah, I'm incubating a small quark.
Okay.
Fantastic. So Addie's having a baby. So... that's
In other words.
Addie is having a baby. It's very exciting.
Yes.
So today's trivia is Addie's baby related.
Oh,
Okay.
that is very exciting.
I think she has an advantage, sounds like. I feel like this trivia is
a minor advantage.
This trivia is rigged.
She may have a minor advantage in this, but just because I'm sure that because she's having a baby soon, I can't remember how many months along / how many months she has to go / how many months it takes to make a baby. You know, I don't know.
You don't know anything apparently.
But or how babies are made. I don't know anything. But
It's not that. It's not that podcast.
Has been thinking about names. And so she may have been looking at baby name lists.
No, but okay.
But if she hasn't, then she doesn't have an advantage. Here's the question.
Okay.
As you know, as astronomers,
Yes,
the sky
we know things.
is divided up into 88 patches, 88 constellations.
Yes.
Which all have all kinds of fun names.
Right.
What I did was
Scoot
I
'em.
looked at...
Waiting for
Sextons.
I looked at... No, neither of those come up here.
Okay.
I think. I looked at a list of the top 1,000 most popular baby names of 2021.
Ooh.
Okay.
2021. So obviously, this is just some website put this together.
Sure.
This is like thebump.com to give them a bump in their
me just-
viewership. Do not 5 constellations
Are
here
in
as
within the
top
top
1,000
1,000
baby
Oh, wow.
in the U.S. Or are we talking in the U.S.?
Yeah, this is probably in the U.S.
And so we have to guess which 5
You have to figure out
constellations.
which 5 constellations are
Some people
top
are
1,000
naming
baby names.
Some people are naming their babies
2021.
after. Okay.
Bonus points.
First, I have to think if I know the names of 5 constellations.
5 constellations.
I know at least 12.
Yeah.
13.
I could probably
But most
come
of
up.
those are not going to be.
I could probably come up with 20 or 30.
Okay.
Yeah. The nice thing is that most of the
Maybe
names
not.
are so ridiculous that they probably
not
like
I know-
Scootum is probably
My next pet might be named
I have
Scootum.
one. I've got one I'm pretty damn sure of.
You got one
Okay.
you're sure of. All right.
Booties.
Okay, cool.
Interesting.
All right. Well, Jim, while Addie and I ponder that, and I'm sure Addie's now going to name her
I think
child
we're gonna have an influence
Booties.
on the name of baby
It
Gov.
might be Booties.
Booties is pretty awesome.
Booties, Scootum,
With an
Gov.
umlaut. With
The name has
umlaut.
already been chosen, so this will not influence that.
All right. Let us move out into the constellation, into the galaxy, and talk about planets where Jim's life is going to be discovered.
Oh yeah. So
Jim's life
has been missing.
been missing for a
Missing
while.
in action.
So.
that's right.
It's
I don't
pretty
know, 3
sad.
years. Yeah, it is. It is. My life is going to be found around mini Neptunes.
Mini Neptunes or Mac. Sometimes, so are they mini Neptunes or super Earths? Because we've heard both of these things.
In between them, really. In fact, they're kind of giving these things a new name. They're calling them Hycean, maybe is how you pronounce this. Hycean worlds that are worlds that mass-wise, I think are similar to. There's something like 10 Earth mass.
Hycean, right?
Things. Hycean.
I don't know. That's
When I first saw it, I thought Hycean, and then Jim said it's hydrogen ocean.
Right. I think that word is a portmanteau of hydrogen because they're hydrogen-rich
love a portmanteau.
atmospheres on ocean worlds.
On ice.
No ice. Ocean worlds.
I was just asking if she wanted her portmanteau on ice.
I'm not allowed to have that right now.
Oh, that's true.
She's pregnant.
What?
Yeah, for a long time, I think when people thought about life in the universe outside of our solar system, they thought Earth-like worlds, right? So you're going to have a world that's rocky with some land and some water and so forth. In recent decades, we've kind of expanded our ideas and thought maybe the icy world or icy moons around Jovian planets might also be a great place for water and life. With the explosion of knowledge about extrasolar planets, we've realized there are other planets besides just Jovian and terrestrial like we have here in our solar system, and there are worlds like kind of in between.
In-betweeners.
That are like Uranus and Neptune, but then there are also other worlds that are kind of more towards that mass range, but are closer to the sun, and so they might be lots of ocean worlds out there. And then we found a few definitive examples of that, worlds that are going to be covered in oceans, but like they're majority ocean. I think something like 10% of their mass is like the rock metal material, and then 90%.
Oh, wow.
Is water.
Yeah.
That's insane.
That is scary.
Understand.
Mostly ocean.
Yeah.
I'm already afraid of our ocean here on the Earth,
deep
which is a tiny fraction of that.
I mean, it's 70%.
I'm going to have nightmares now about Neptune-sized oceans.
Ocean, yeah. Oh my God.
Deep
with
life,
with all sorts of alien
teeming
life
organisms.
in there.
So anyway, we're coming to the conclusion that there may be a fair number of those things out there, and those seem like reasonable places to have life. And so, how would you detect life? And we talked about this when we were just talking about our answers to the thing. But how do you detect life in a place like that? Well, obviously, barring going there, one of the main ways to do it is by looking at the atmospheres of these things. These atmospheres, if they have a large amount of things that shouldn't be there, and oxygen, of course, is probably the prime example. Our atmosphere has 20-something% oxygen, O2, but it shouldn't, right?
Yeah.
Oxygen is very reactive, and if you give it any length of time, it's going to combine with other things to go away.
Yeah, but we keep making it.
We keep making it, right? We keep pumping. I say we.
We don't.
We don't, but
we
plants
use it.
do, right? And algae does. Photosynthesis pumps out oxygen, which means that we have a continuous source of oxygen in the atmosphere. So if you find another planet that has a lot of oxygen in its atmosphere, that's at least intriguing. There are, of course, abiotic, non-biological ways of pumping oxygen into atmospheres, but
oxygen is just super reactive.
It's super reactive. And
so
the more of it you have in the atmosphere, the less likely it is that it's some, non-biological process. But anyway, there's a lot of, like we said, there's a lot of technology and theory going into understanding how to figure out what the atmospheres of these planets are made of. We're getting better and better at it. And since we think there are a lot of these, and bigger worlds, the nice thing about these mini Neptune or Hycean worlds is that
we'll have to find out if it's Hycean or Hycean.
Hycean.
It looks like Hycean until you know what it's.
The word ocean, though.
Until the word ocean pops up.
Ocean. I'm going to start pronouncing it.
Ocean. Yeah.
But
you're not my reference for word pronunciation, by the way, Jim.
No.
Just going to throw that out there.
Fair enough.
So, yeah.
I should be. I pronounce everything.
Maybe maybe it hasn't been really defined in how you say it yet. We could make it.
Authors just made up this word.
Yeah.
But I like the word, actually. I think it's a cool word. I like it. I'm going to play it in Scrabble.
Okay.
See if it gets challenged.
Ooh, I'll challenge it.
But it's nice because they're bigger, right? It's the trouble with these Earth-like planets is they're so hard to find,
so small,
and their atmospheres are very thin, and they're going to be hard to analyze these things. The bigger the world, the easier they are to analyze, and so if we have big worlds on which life could be found, it's going to be easier to find them than on small worlds.
Yeah,
So exciting.
We can use things like JWST, potentially, upcoming mission, to look for these signatures.
So
this year.
One of the planets that, when is JWST? Is in November launch now?
I think it's now. It was October 31st, but I think it's now November. But they did just announce that they NASA finished checkouts and stuff like that on the telescope.
Wow.
Oh, gosh.
Ready for launch.
It's really happening.
Big
How are
milestone.
they getting it to the rocket from wherever it
You were going to
is?
say to space. I was going to say a rocket. I think it's...
A big boat.
Where is it right now? I thought it was...
Well, in the US of A, I think.
Yeah.
And it's launching from French Guiana on an Ariane 5.
Yeah. Probably a big boat.
I guess.
Oh my gosh. If that boat sinks,
Maybe an airplane?
I don't know. I'm just curious. Hadn't thought about it. One of the planets, one of these potentially Hycean worlds. Hycean worlds is K2-18b.
Oh.
Which is 2.6 times the radius of the Earth. Mm-hmm. For reference, how big is Neptune in size? I think it's 4 times the radius of the Earth. So it's one of these in-betweeners, right? Mm-hmm. It's significantly bigger than the Earth.
Goes through the Panama Canal.
Oh, okay.
Yeah.
Significantly bigger than the Earth, significantly smaller than Neptune, and it's orbiting a fainter star, but in close. So it's in, actually, this particular planet receives the same amount of energy from its star as the Earth receives from the sun.
Total, energy per unit area?
Per unit area per second. Yep.
Interesting. That's good.
About 1,400 watts per square meter.
For keeping
We like that.
liquid.
Which is our favorite number of watts per square meter.
It wouldn't be liquid unless there's an atmosphere.
Right.
Yeah.
Right.
And that's the other key aspect of these things, right? They have atmospheres, and specifically hydrogen-rich atmospheres.
Did you say atmospheres?
That doesn't mean... No.
Okay.
Atmospheres. It doesn't mean just pure H2 in the atmosphere. That means things like H2O.
Mm-hmm.
And in this particular planet, K2-18b, it orbits its star in about a month, 33 days. The star is 2.5% of the solar luminosity, but because it's much closer in, again, it's getting that same amount of energy that we get from the Earth. Mm-hmm. And they do believe that they've detected water vapor in the atmosphere of this planet.
Yeah.
So,
and there are about 11 potential candidate planets that they
for these Hycean worlds.
List. Yeah.
So I'm kind of with Jim coming back to the stumper, bringing things full circle. Which I love to do. Mm-hmm. If you've ever been to one of my intro classes,
he does love to draw a full circle.
I love to draw a full circle on the blackboard. Bringing things full circle to the stumper, I'm kind of with Jim. I'm sort of skeptical or pessimistic or cynical, depending which one you want to go, about life in our solar system, including Earth, actually.
Yeah, I'm pretty cynical about life on Earth also.
But for extraterrestrial life, I'm betting outside the solar system, and I love the idea. I'm hanging my hat. I'm pinning my dreams, my hopes and dreams on the chemical composition of exoplanets.
Okay.
That we're going to see some transiting observation. We're going to see some whopping signature. That's where I'm hoping.
That's a tenuous hook to hang your hat on.
It is.
Yeah.
And I need a hat. So it's a little bit of a tenuous situation overall, I have to say. Okay.
It's tricky.
Well, we'll see. We'll see what the next 29 years, and we'll tune in on episode 3026 of Walkabout the Galaxy to find out which one of you won that stumper. So 5 constellations. How do you want to do this, Jim?
Well, we're going to do it.
There's 88 to choose from.
We're going to do it Boggle style.
What does that mean?
Do you play Boggle?
I have played
Boggle. What I mean is, do I make 5 guesses and then Addie makes 5 guesses, or do I do one guess and she does one guess?
In your head, well, I don't know. We'll see. Well,
okay.
Now you got to know. Make a decision.
We'll take turns. Addie.
Hi.
Goes first. Okay. Oh, because she's pregnant.
She's pregnant, so she gets to go first.
Yeah, I'm trying to think of. Lyra.
Lyra. Correct. 1 point for Addie. Lyra is the 289th most popular.
You shouldn't have said
baby name.
You shouldn't have said correct. Maybe I would have said Lyra too.
That's how we're doing it. Apparently,
now I changed.
Now you get to go.
We're not doing a bug style.
Leo.
Leo. That is the number one answer. Good job. So if
Nice.
this were Family Feud,
You'd get the
I
most
would have
points.
more
One
points.
answer.
Yeah.
Nice.
that was the 74th most popular
Damn
name
straight.
Wow.
Yeah.
of 2020.
Nice.
That was the low-hanging fruit.
2 for 2. That's pretty good. Yeah, Leo is the low-hanging fruit. Lyra, that was good.
That is
I
pretty
have
good.
a friend who named their kid Lyra.
Yeah. Okay.
Made me think.
All right,
And then
well,
I
there's-
realized only recently that that's a constellation.
Yeah.
And I was like, oh, yeah.
3 more. Addie, your turn. This is going to get tougher.
Yeah.
Real tough. Real quick. If you have to bow
It's
out.
not going to be booties.
Not booties.
Can we get some hints?
If you
Are
have to
giving
bow out, I
hints?
found, by the way, 6 other astronomically related names in that 1,000.
Yeah.
So you get
Okay.
Oh, fun.
a backup point. if you-
What about...
I will tell you that I think 2 of them are male names, one's female.
Interesting.
But
Josh, do you have another one? You
I
look
do.
like you have another one. Let's Josh go next.
all right, Josh, you're up again.
I'm going to go with my man Orion.
Orion.
Oh.
Excellent.
I was trying
He is
to
also
decide,
on
yeah.
the list. 263rd most popular name, Orion.
Nice.
I was impressed with that as well. I wouldn't have thought. I've
People would
never
name their
met
kid
anybody named
Orion?
Orion, but
Yeah.
they're out there.
Is it O apostrophe Ryan? So,
Jimmy Orion.
yeah.
I am impressed with you guys. 3 for 3.
Yes.
No wrong answers yet. That's amazing. Excellent. 2 more to go.
Karina.
Oh, I like that one.
On the list. I also like that.
I like it.
Yeah.
People should be naming their kids Karina.
Agreed.
Yeah.
Yeah, one of the prettiest things in the sky is
The Ada,
Eta Carina.
Mm-hmm.
Yeah. A gigantic star sort of
exploding.
that can't keep itself together.
Yeah.
That's really
I feel like that a lot.
All right. I'm going to go then with Perseus.
No, Perseus, not on the list.
Okay.
That's not a bad guess, though. That's like an old-timey name, kind of.
Okay.
I'm like
one that
blanking
starts
on all the
with the same letter.
constellations right
As
now.
P.
Yeah, there's a P name.
A P
I guess that's
name.
just kidding. That's not a guess. Should it be a guess?
I don't think so.
A name that's rising from the dead these days.
Oh.
A name that's rising from the dead these days.
Yeah, it's popular
What-
again. Rising from the dead.
I can't think of. Oh,
the name.
Phoenix.
Phoenix.
Is Phoenix a constellation?
I didn't know that.
Constellation.
I'm completely
called
unfamiliar
Phoenix?
with that constellation.
There are all these
Where is it?
constellations, especially in the southern hemisphere, that I've
Yeah, I
never
was gonna
heard
say,
of
is it
either.
Southern Hemisphere?
I don't know where it is.
Oh, Phoenix. Okay.
Okay.
All right, you have one more
One
to go.
more.
This one is a name that sounds kind of like a name.
Okay.
This is one that those.
I guess it's not. I guess it's not telescopium then.
Sextons. It's not like the dolphin.
Constellations. Do we know?
Ursa Majoris.
This one is one of the zodiacal
Oh,
constellations. No, is that true? Maybe.
I don't know. Well, come on, figure it out, professional astronomer. Jeepers.
Jeez.
Aries.
Aries. There it is. You got it.
Really?
Perfect. So yeah, Leo, Orion, Lyra, Phoenix, and Aries. Those are the
Phoenix.
Phoenix.
Those are all
Well, the Phoenix
names.
is a name I see, but I did not know it was constellation.
Yeah, I didn't know that was a
Yeah.
constellation.
There's
Okay.
some other random astronomical ones that I found on the list. Luna, Stella,
Oh, yeah.
Nova, Sky, Venus, and Aurora are all
Yeah.
Those are
astronomically
nice.
related pretty names.
Yes.
I like those.
Excellent.
Good. Although Aurora, is it astronomical or meteorological?
That's a good question. I'm
yes.
going to call it both.
Okay.
Yeah.
Yes.
Yep. All right.
Fun.
That works for me. So, what's your baby's name?
Her middle name is Karina.
Yeah.
Is it really?
Yes.
Oh, you heard it here first, folks, on Walkabout the Galaxy.
Yes.
Yes.
Did you know that, Jim?
I did.
Jerk.
I did. And I was surprised.
I guess
'cause
you
I thought
didn't
that was
hear
a
it
really pretty name. I'm
here
surprised
first.
that wasn't.
They all
Jim heard it here first.
I haven't known long. I only found out that very recently. And I thought it was really
Is
pretty.
her
I was
first
surprised
name
to not see it on
Ada?
the list of 1,000.
It's not.
It's not the Greek letter Ada?
No, it's
be
not. That would be
so
fun
awesome.
though.
Ada
Man,
Karina?
Or to do like ADA Ada. That would be
Is
kind
it
of fun.
is it
too.
Karina with an E at the end or just
No.
Carina?
Yes.
Very nice. Okay. Well, while it may have felt like banging your head against an asteroid on a collision course with Earth,
Very gently.
it was just another episode of Walkabout the Galaxy. Give us 5 stars and we'll give you the universe. You know what? we'll give you the universe anyway, because that's just the kind of people we are. Be sure to follow us on Facebook and Instagram to get all our updates, and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel, where you can see most of our episodes, some of our bloopers, and all of our music videos. Catch up on old episodes wherever you get your podcasts. Follow us on Twitter
at walk_the_galaxy.
And ask us questions anywhere using hashtag AskWTG or AskWTG@ucf.edu. Our theme music was composed by Richard Rusik. Production assistance was provided by Diego Rodriguez. Thanks to our listeners in Mexico and around the world. Stay safe. I'm Josh Caldwell.
I'm Addie Dove.
And I'm Jim Cooney.
We're the Astroquarks, signing off until the next episode of Walk About the Galaxy. Karina.
Yay.